In this demo, I will show you how to determine the internal resistance and EMF of a zinc carbon battery. There's my inexpensive battery. Here is my LabQuest and the differential voltage and current sensors, or voltmeter and ammeter. And then in the circuit is a potentiometer, or a variable resistor, that will change the resistance, and I'll take it from about 20 ohms down to 0 ohms to see how that affects the potential and the current. And then plotting that, we can determine the internal resistance and the EMF. So we'll go ahead and switch over to the graph. There we go. And you can see it's potential on the y-axis and current on the x-axis. So we'll go ahead and start recording. And then I'm going to take the screwdriver to adjust the potentiometer. And as I turn the resistance down, you'll see that the voltage decreases as the current increases. When I turn the resistance back up, you'll see that the voltage increases as the current decreases. And eventually it peaks out where the resistance pretty much stops the current altogether. So then, go ahead and stop recording. And if we analyze and do a curve fit, linear, you'll see that the slope m is negative 1.08. This is our internal resistance. So m is equal to negative r. That means that our battery, this guy over here, has an internal resistance of about 1.08 ohms. The b, the y-intercept, that is our electromotive force, or EMF, or as I call it in class, fancy E, of 1.57 volts. That makes sense if you look at the voltage probe. The voltmeter shows that it's about 1.516, and when you are draining a battery, as we're using it now, that means that the terminal voltage V is less than your EMF, which was shown in the graph here.